8.4 Adding, subtracting, multiplying radical expression. So first we're going to look at adding, subtracting radical expression. To add or subtract is basically like combining like terms, but however this time we're going to be combining like radical. There are three things that need to satisfy in order to talk about it as like radicals. First, it has to be the same index. Second, has to be the same radicand. And third, has to be like terms also. Okay. So, now, first up, when we look at the first example, to combine the radicals, first we have to look at is the radical completely simplified in each term or not. In this case, yes, because we cannot simplify any further. So the next, we need to check which are the like radicals. When I look at the index, all the index are the same because it is 4. And next, I'm going to check my radicands. The radicands, all of them are 5xy. So all the radicands are the same also. So finally, I need to check are they like terms or not. So when I check that, like term basically means what the variable outside of the radical, it must have what the same variable and the same exponent. So therefore, this first term and this last term, they are like radical. And the middle two terms are also considered like radical. Okay. So now that we notice that which are the like radicals, we can combine their coefficient. So combining coefficients, 2 minus 4, which will give me negative 2x fourth root of 5xy. And then combining the two middle terms, shall become negative 1 plus 7, which will give me plus 6 fourth root of 5xy. And this will become my final answer. So this is an example for you to understand which is what does it mean to be like radical. Starting from next example, we're going to have to always consider first, can I simplify the radical in each term or not? Only after you simplify the radical in each term, then you will be able to determine are they like radicals or not, and then combine them together. So let's take a look at the next example. No matter how many radical terms I ask you to add or subtract, you will not write more than 4 steps. Okay, so make sure you follow closely on this step. That will be basically the step that I taught you on the simplifying radical expression from previous session. So the first thing that we're going to look at in here is what is my index, so that I can simplify each radical term. So in this case, my index is cube root. So to simplify the first radical term, I go one by one. First the number 81, and we practice enough such that we know 81 has a perfect cube factor, which is 27 times 3. And then I can rewrite it at x to the 4th power times y to the 4th power minus 1/2 x times cube root of, for the second radicals, negative 24. We also know that negative 24 has a perfect cube number, which is negative 8 times 3. And then times x times y to the 4th. Now, I'm going to using the product property to simplify the radicals. So it'll be 2/3, Remember, anything that coming out from the radicals is a factor, so it will be 2/3 times cube root of 27 is 3. For the variable part, you have to remember that the exponent of the variable will be divided by the index. The quotient will tells you how many what is the exponent of the variable outside. The remainder will tells you what is the exponent of the variable inside the radical. So for x to the 4th power, 3 goes into 4 one time, so therefore x comes out. And right away inside, I want to write it down what is left over. So 3, and then the remainder is 1 for the x, so it will be x coming. Then for the variable y, 4 is the exponent of the variable y. So 3 goes into 4 one time, so y comes out, y to the 1st power come out. And the remainder is 1, so y stay inside. So this is basically the shortcut that we talked about in the previous session. Okay. Minus 1/2 time, or 1/2 x times. Now, cube root of -8, that is -2. And then inside the cube root, right away I will write it down, 3 is left over. X, I cannot simplify any further, so that will be x, because the exponent of x is smaller than, less than the index, so we cannot divide it. But y is y to the 4th, so I can divide. 3 goes into 4 one time, so y comes out, and then the remainder is 1, so y stays inside. Now, simplifying a little bit further on each term, 2/3 times 3, that will become just 1, so it will be 2xy, cube root of 3xy. Negative and negative become positive. 1/2 times 2 is 1, so it will be xy, cube root of xy. So finally, the last step, now we can see that, oh, I forgot my 3 right here. So now I can see that these two terms are like radical because they have the same index, 3. They have the same radicand, 3xy. And also they are like term because outside the radical, both term has x and y. So now I can add the coefficient, which is 2 plus 1 will give me 3xy, cube root of 3xy. And this will be my final answer. So no matter how many terms you have, these are the 4 steps that you will always do. So you should not write more than 4 steps, okay, to save your time. So let's take a look at on the next example. So try to pause it and then see you can sort of like, work this out from your first example. So the first step, I'm going to simplify each term. So cube root now I want to find out 256 has a perfect cube factor or not. So 256, that is basically 16 times 16 is 256. 256 is 16 times 16. So therefore, I can see that 16 is 4 times 4 and then 4 times 4. So I can see that a perfect cube factor for this 256 is 64. So let's double check. Is that 64 times 4 gives me 256? Yes, it does. So now I can write it down as 64 times with 4 times y to the 5th plus y times cube root of 32. And we know that 32 has a cube root, perfect cube factor, which is 8 times 4. 8 is a perfect cube factor times y to the 2nd power. Now, simplifying each term, continuing using the product property, cube root of 64 is 4. So inside the cube root, 4 left over. Now the variable y has exponents 5, so 3 goes into 5 one time, so y comes out, and y to the second power stay inside because the remainder is 2. Plus y times cube root of 8 is 2, so inside the cube root it will left with 4. Since the exponent of y is smaller than index, we cannot simplify, so that we'll just write it down. Now, continue simplifying a little bit. So that will be 4y times cube root of 4y squared plus 2y cube root of 4y squared, which give us 6y cube root of 4y squared, because they are like radical and we can add them up together. Next is multiplying radical expression. Recall, you can only multiply two radicals if the index of the radicals are the same. And of course, the radicand must be greater than 0, and n is basically greater than or equal to 2. So for the first example, I have 1 term times 1 term. So I can basically multiply 2 times 3, that gives me 6. Because of the index of the radicals is the same, I can multiply the radicands together. So this will become 4th root of 20y squared times with 28y to the 3rd power. So from here, I can basically simplify this. 20 and 28. So here's a few ways that you can do. If you are good at calculator, you can go ahead and multiply first and then continue reducing. Which, let me point this out. 20 times 28 is 560. That is a very big number for you to break it down of the looking for the perfect 4th power number. Okay. So let me recall for you how to break this down. Okay. So 20 times 28 is 560, and y squared times y give me y to the 5th power. Now let's try to break it down, this 560, the way that I taught you before. So first you're going to think about 1 to the 4th power, right? We want to look at the perfect 4th power number. So 1 to the 4th power is 1. That's not going to do any good for us. 2 to the 4th power is 16. Right? So now I have to think about that 16 is a perfect 4th factor for this 560 or not. So I'm going to divide 560 by 16, which give us 16 times 35. And clearly 35 has no perfect 4th power factor anymore, because this is only 5 times 7. So therefore, this is a good number to use. So now I can break it down as 4th root of 16 times 35 times y to the 5th power. And using the product property, 4th root of 16 is 2. So inside the 4th root, it will left with 35. For the variable y, the exponent is 5, so therefore 4 goes into 5 one time, so y comes out. The remainder is 1, so y stay inside. And now the final answer will be 12y, 4th root of 335y. So this is 1 term times 1 term. Now 1 term times 2 terms. So this is basically recalling the distributive property. So first what we're going to do is we're going to distribute it. Since we can only multiply, right, since we can only multiply the radicands together when the index are the same, cube root of 4 times negative 2 will be just negative 2 times cube root of 4. But for the second term, since they both have cube root, I can basically multiply the radicand together. So that will become minus cube root of 4 times 6. That will give me 24. Now, we need to simplify this, which is negative 2 cube root of 4. 24 is basically 8 times 3. So after we simplify it, that will become negative 2 cube root of 4 minus cube root of 8 is 2, cube root of 3 left inside. And this will be my final answer because they are not like radical and we cannot combine them. So moving on to the next example is multiply a binomial times a binomial, which is 2 terms times 2 terms. So we're going to do the foiling method. First, we're going to multiply first together. So therefore, 6 times 3 is 18. And then we're going to multiply the outers together. So that will become 6 times 4 square root of 7, which will give me plus 24 square root of 7. And then we're going to multiply the inner together. So negative 3 square root of 7 times 3, that will give me negative 9 square root of 7. And finally, we're going to multiply the last together. So that will become negative 3 times 4 is 12. Square root of 7 times square root of 7 is 49. Square root of 49. So we know that from here, continue simplifying, that will become 18 plus, these two terms are like radical, so that will become 15 square root of 7 minus 12 times square root of 49 is 7. So finally, when I continue simplifying this, that will become negative 12. You can use your calculator, right? In this 12 times 7 is 84, and then 8, you need to combine with 18, so negative 84. So my final answer will become negative 66 plus 15 square root of 7. That will be my final answer. Next example, same, right? We need to do the foiling. So first step, multiply the outers together. Cube root of x times cube root of x, which will give me cube root of x times x is x squared. Then multiplying the outer, cube root of x times negative 3 will be negative minus 3 times cube root of x. Multiplying the inner together, negative 2 times cube root of x will give me minus 2 cube root of x. And when I multiply last two terms together, negative 2 times negative 3, that will become positive 6. So finally, we can simplify this because the middle two terms are like radical. So it will be cube root of x squared minus 5 cube root of x plus 6. That will be my final answer. Next example. So for this example, we're going to use the shortcut formula. Remember that first plus last quantity square, that is first square plus 2 times first time last plus last square. Or you can split it out into 2 factor and then FOIL it. But I would recommend you practice using the shortcut formula and then practice mental math so that it will help you to move faster on the tests and quizzes. So, according to the shortcut formula, it will be first square plus 2 times first time last plus last square. So my first is 1, first time last, and then last square. So 1 square is 1 plus 2 times 1 is 2. 2 times 3 square root of 6 will become 6 square root of 6 plus 3 square root of 6 quantity square. So remember, according to the properties of exponent, the square is going to apply to the factor 3 and also factor 6. So 3 to the second power, that will be 9, times with square root of 6 square. Square root and square, they cancel it out, so it will become what? Just 6. So therefore, it will become 1 plus 6 square root of 6 plus 54, which my final answer is 55 plus 6 square root of 6. That will be final answer. Last up, this is an example that we're going to have to reuse when we talk about rationalizing denominator. Notice that this is difference of two square format because I have first minus last and then first plus last. So according to the formula, this will be equal to first square minus last square. Shortcut formula. So these two factors are called conjugate factor. Conjugate factors are identical terms except the operations are opposite. So now, using the formula, this will become first square minus last square. So first is 3, my last is 2 square root of 5. 3 to the second power is 9 minus, again, according to the properties of exponent, we're going to be squaring the first factor and then squaring the second factor. 2 to the second power is 4 times with square root of 5 square. Square and square root, they cancel it out, so it will become just 5. So now this will become 9 minus 20, which will give me negative 11. So what we want to put in notes and then remember is, when you multiply the conjugate factors together, your result will be always what? Radical free. And this idea we need it for the next session. And this concludes the sessions.